Okay, we're going to go over the Precalculus Preview. Some of you are taking Precalculus while you're taking geometry, which is great. This will be helping you for calculus. So these are identities that you will encounter. The reciprocal identities, quotient identities, Pythagorean identities, coterminal identities, even and odd identities. So what we're going to do today is we're just going to go over the reciprocal identities, and you're going to add them to your notes. So sine theta is the same as the reciprocal of 1 over cosecant theta. Cosine is 1 over sine theta. Identities are something like multiplication tables. The more you know by memory, the better it's going to help you. The cosine is 1 over secant theta. The secant is 1 over cosine theta. Tangent theta is 1 over cotangent. And cotangent is 1 over sine. So it's the reciprocal of sine theta. We're familiar with a circle. Many of you already have precalculus and familiar to this unit circle. But let's name this. This will be X, Y, and R. All right, so here we're going to identify some rules for Pythagorean identity. We know from the triangle x squared plus y squared is equal to r squared. X is going to be cosine of theta. Sine, we're going to say, is equal to sine of theta. R, we're going to say, is 1, like it's a unit circle. So x squared would be cosine theta squared plus y squared is sine theta squared equals to 1 squared, which is the r squared. Cosine theta squared would become cosine squared theta plus sine squared theta is equal to 1. That's an identity rule. I can rewrite this by dividing everything by cosine squared theta. When I do that, this becomes 1. So I have 1. Sine over cosine is tangent, so that would be tangent theta equals 1 over cosine is secant theta, so it'll be squared. Same thing if I was to divide by sine squared, then this would be cotangent squared theta plus 1, because I did sine squared divided by sine squared, equal cosecant squared theta. So we got our 3 rules from this sine squared theta plus cosine squared theta plus sine squared theta equals 1 squared. So we have our 3 figures here, our 3 Pythagorean identities just from this identity, right? We're not going to talk about even odd today, but we are going to go over here to recall our Sohcahtoa. If x is cosine theta and y is sine theta, then the tangent will be y over x, which is opposite over adjacent, which is the sine theta over cosine of theta. Cotangent will be the inverse of that. That's x over y. So that would be cosine theta over sine theta. So what are you saying? Well, I got cotangent is cosine over sine. I got tangent is sine over cosine. Now let's talk about our coterminal identities. If this is my A here, and this is X, and this is Y, and this is R, this is simply doing what you did in a lesson this week. Sine of A would be Y over R. Sine of B would be X over R. Cosine of A would be adjacent over R, which is X over R. Cosine of B is Y over R. Right? Did you notice that the sine of B is the same as the cosine of A? That's interesting. So we also can know that A plus B will equal to 90 degrees. 90 degrees can be written as pi over 2. So we know that B would be equal to pi over 2 minus A. And so basically what we're doing is just rewriting some of the statements to come up with some coterminal identity rules. Just a minute. So we can see that the sine of B would be the sine of pi over 2 minus A. The cosine of A would be the sine of pi over 2 minus A. Because of this relationship up here, they're the same. So I can write this because of that. I don't want the notes to be over 10 minutes, so let's just go ahead and write out what these mean. Sine of A is the same as sine of pi over 2 minus A. Tangent of A will be cotangent of pi over 2 minus A. Secant would be the cosecant of pi over 2 minus A. The sine will be the cosine of pi over 2 minus A. The cotangent will be the tangent of pi over 2 minus A. And the cosecant will be the secant of pi over 2 minus A. So this is going to be your go-to document for various identities. We're going to wrap it up with the even and odd. Even function rule. F of a negative x is equal to f of x. Comes out to be even if the x quantity is negative. If the x quantity is negative, here on an odd function, it will come out to be a negative function. So here are the rules. Cosine of a negative x is the same as cosine of x because cosine is a positive function. An even function, I meant to say. Secant of negative x would be secant of x. Sine of a negative x would be a negative sine of x. Cosecant of a negative x would be a negative cosecant of x because these are odd functions. Here, tangent of negative x will be a negative tangent of x. Cotangent negative will be a negative cotangent of x. So when you see a negative quantity here, you know that it'll come out to be a negative tangent x. Same here for cotangent. The even functions are cosecant, cosine, and secant. The rest of them are odd. And there you go. You have your notes. I suggest you keep this in your notes so you'll be able to review it and go back to it when your teachers start going over identities. You're welcome.